Welcome to the Real Python Podcast. This is episode 118. How do you start building your project documentation? What if you had a tool that could do the heavy lifting and automatically write large portions directly from your code? This week on the show, Christopher Trudeau is here, bringing another batch of PyCoder's weekly articles and projects. We talk about a Real Python step-by-step project from Martin Breuss about MkDocs. The project walks you through generating nice-looking and modern documentation from Markdown files and your existing code's docstrings. The final step is to deploy your freshly generated documentation to a GitHub repository. Christopher talks about a pair of articles arguing for and against using Python dictionaries. The first article, Just Use Dictionaries, pushes to keep things simple, while the second article, Don't Let Dicts Spoil Your Code, contends complex projects require something more specific. We cover several other articles and projects from the Python community, including discussing the recent beta release of Python 3.11, 2FA for PyPI, procedural music composition with arvo, building a Tic-Tac-Toe game with Python and Tkinter, a discussion covering common issues encountered while coding in Python, a type-safe library that generates SVG files, and a lightweight static analysis tool for your projects. This episode is brought to you by Snyk. Snyk is the security platform designed for developers, securing the software development lifecycle from the tools and flows devs use. Sign up for free at snyk.co/realpython. That's snyk.co/realpython. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey, it's been a while.
Yeah, I know. How's your summer been?
Summer? It's hot out. Yes,
Yeah.
Summer.
It's hot. Yeah. Thought we'd come back and do a little bit of news stuff, just kind of a short set of almost kind of release notes kind of things. It's just sort of top line stuff. So did you want to start that?
Sure. The first ones, we've come across a piece inside of one of the Python mailing lists just a couple of weeks ago that indicated that they're kind of behind on the release schedule for Python 3.11.
Okay.
And on top of that, already being behind, they're not entirely happy with the stability of the current beta. And so they've been discussing with the steering committee whether to add a couple of more betas. And if that happens, it might mean 3.11 won't go until maybe December.
Okay.
I like the fact that they have timed releases. It makes things predictable, but I'd really rather stable than unstable. So let's hope it goes smoothly from there, and we'll get it a little later. Christmas present.
Okay. And it currently scheduled October, so there's a little bit of play room in there.
Correct.
Okay. Yeah, kind of on top of that, there was a tweet and then a post on python.org about, I don't know, there's been like this whole trend of them calling the latest releases cursed, just because of things that are happening during the releasing of it. And this one, they just had a real, all caps, please help us test this release thing. And due to the modified release schedule and the stability concerns regarding the past beta releases, please help us test Python 3.11 by testing this beta release. And they had this whole bunch of lists of stuff. If you maintain a library or a third-party package, test the beta release. If you have code that you maintain at work, research center, classroom, whatever, test the release. If you're a multi-million corporation that uses Python, test the release. And even down to the single person.
I'm detecting a pattern here. Test the release. Yeah.
Yeah, exactly. If you use Python for work, research, teaching, literally anything, test the beta release. So, and it's not hard to do. I know it's some work, but getting the beta releases is not difficult to do.
Well, And particularly seeing as you should have automated testing for all your code anyways, it really is just a matter of installing the new release and running your own unit tests. So
there you go. Should be on top of that. The second news item in the Python world is a change with PyPI and two-factor or 2FA. They put out a tweet thread, and then there's some additional stuff on that. They've begun rolling out 2FA requirement. That kind of brought up some other stuff that we're not going to deal with here, but they began rolling it out. Soon maintainers of critical projects must have 2FA enabled to publish, update, or modify them. And so along with that, they have a post on pypi.org. That one is to ensure these maintainers can use strong 2FA. They're distributing 4,000 of hardware security keys. Those are USB style keys, either standard USB, I guess, A and USB-C style. Project eligibility is based on downloads. Any project in the top 1% of downloads over the prior 6 months is designated as critical. Out of 300,000 different projects, they're talking around, just over 3,000 or so. Anyway, they've notified people via email. And anyway, you can kind of look at the information there. I thought it was interesting that they chose hardware keys, and they had some links to some information about that. And also a really good FAQ about the program if you're curious, some of the details, and hopefully you can get some of your questions answered instead of screaming out into the void of like, what is this? And they had this link to getting two-factor right in 2019 on the Trail of Bits blog. And what I found interesting about that is even back in 2019, they were talking about how what I use for authorization for most things, which is tools like Authy or the Google Authenticator app that use like a QR code kind of thing. I guess there's some potential pitfalls there. And so this article kind of gets into that. So I'll include some of the links. And I guess we got to wait for the next level, which is going to be hopefully the authorization with our devices, which seems to be coalescing and coming together. So I hope that will make it easier. A little bit of news at the top there. Do you have any other notes there?
And of course, this is all to mitigate the potential of people stealing each other's repositories. And we've talked about that in the last couple episodes, that there have been some issues lately. So really, as far as I'm concerned, I know that anytime this kind of thing happens, there's always a bit of a fuss, but I think they're trying to be responsible. And the internet will debate because it's the internet, but I think they're trying to do the right thing.
Right. And the 1% of the 1% will, be upset, but hopefully that doesn't get amplified.
Yeah. So. Well, and I think it should be constituted a bit of a badge of honor, right? If they want to ship you a key, that means your repo has been massively successful, right? So
which is nice. Yeah, that gets us into articles and tutorials this week. I'm going to start with one from Real Python. It's by previous guest Martin Breuss. And it's a step-by-step project. I think actually both of our Real Python ones are step-by-step things. This one is titled Build Your Python Project Documentation with MkDocs. Things that I thought were really nice about this, it provided a really good set of best practices for not only kind of documenting your code internally, things like docstrings and so forth, but also like what are best practices as far as the types of things that need to be created for documentation for your own packages. Like if you're going to put up something on GitHub and you want to share it openly, this project, what are the things you should be thinking about as far as documenting it? And if you've done documentation within your code, such as putting actual docstrings in with your functions and so forth, there are tools that can help you create really nice, pretty documentation kind of automatically, or even better, as you make changes, update all the documentation for you too, and actually output a set of HTML files and so forth that you can then host, say, GitHub page also. And this takes you through that. It starts with a really just total example project. It's a simple calculator tool. So there's the functions are like add and multiply and so forth. But that's really not the point. The point is to kind of get you into the mindset of using these tools. There are some kind of big prerequisites. Like you should be at the point of thinking about quote unquote a project. Hopefully you're familiar with virtual environments, using pip to install packages, but also like freezing requirements, and then how to organize your code into modules and packages yourself. So there's some really good resources for each one of these, as I'm mentioning, on Real Python that are linked also. So there's good links to kind of get you up to speed. And then fundamentals of code documentation, and then kind of the basics of GitHub and GitHub repositories, going beyond, using Git on your local machine, but also pushing code in and out of a repo and so forth. In the tutorial, you work with a tool called MkDocs that produces static pages out of Markdown. And then it also can pull in documentation from your docstrings using another tool that's kind of related, MkDocstrings. And then again, lots of best practices stuff. And then we've talked about lots of sort of themes that kind of help you with sort of CSS and making stuff look a little nicer. In this case, they're using the Material set of standards from Google. And so there's a package called Material for MkDocs, which is sort of theming everything to make it look good. And then at the end, you're sort of hosting the documentation up to the GitHub pages. So I won't go all the way through step by steps, but you basically are setting up the environment, creating your Python package. Again, there's a sort of built-in one. You're writing your docstrings. And that is one of my first takeaways is I didn't know there were so many standards for docstrings. They mentioned 3 in the article. And the one that I'm most familiar with is the Google one. I didn't know that it was actually labeled as that, but that was the style that I've seen the most. And maybe that familiarity makes me feel like that feels like the best one for me. There's a NumPy style, and then there's a Sphinx style. That's the ones that are mentioned and sort of linked there. I learned there's 3 other ones that are also potentials ones there. And that led me to a kind of a cool takeaway is there's a VS Code tool called AutoDocstring that you can download as, kind of a plugin for VS Code. And it'll help building your docstrings, generating them for you. And you can kind of, in your preferences, choose which style you would like it to help you kind of format in there, which I think is really nice. Again, things to help kick you in the direction of doing better documentation. And that's the whole point behind this. That whole area of docstrings, creating them under your functions and then writing examples that you could potentially use testing through doc tests, which we've mentioned recently, type hints and providing automatic type information, and then kind of going further into what kind of docstrings are inside of actual modules, and then starting to use those tools using MkDocs and building the documentation and then hosting it up in GitHub. So I think it's a good resource for anybody who's interested in taking this to the next level and diving in and wanting to make good looking documentation and not knowing where to start. This, I think, will get you up and running pretty well, and lots of additional resources and, like I said, best practices. You were mentioning to me that you're more of a fan of using the Sphinx tool, right?
Yeah, I've never actually compared. It's just where I started, and so I haven't had a reason to go do anything else. But most of the libraries that I maintain, I use Sphinx, and there's connectors to read the docs, so you can push it all up, and GitHub will read the docs, will pull it out of GitHub and maintain it up on the main site. So
yeah, the docstrings for the Sphinx style, I wasn't that familiar with. It has lots of extra colons in there. I was just like, that's looks different, but it makes sense that you kind of have to preset a bunch of rules to kind of have it identify these elements to separate them out and put them together.
yeah, it's really just another way of tokenizing things. I do find I use it fairly often, but it's one of those things I often seem to have to look up. There's basic things like the parameter on the function or on a method. I remember how to do that because I do it often. Every time I try to put in a reference to another class and I want that to show up as a link, I almost always have to, is it colon backslash?
Yeah.
What is, and I always have to look it up. So
Yeah, I think that's pretty common. So what's your first article?
it's actually 2, just for variety's sake.
All right.
It's kind of a head-to-head thing. The first one is called Don't Let Dicts Spoil Your Code, and it's by Roman Imkolov. Roman's premise is that as your code grows, those simple dictionaries you use to store data may become harder to maintain. And one of the examples of this highlights what happens when you have a function that takes a dict as an argument. This can be really fragile, right? An upstream change to the dictionary, say renaming a key or adding a key, could impact the function, and it's not going to be discovered until runtime when the function fails. And it's really hard to type this kind of stuff and catch that with MyPy or something along that lines.
Okay.
So Roman goes on to describe the use of a good use of dicts, which is what he calls the wire format. And due to, well, the internet, JSON has sort of become the de facto standard for a lot of data interchange. And it only takes a single line of code to go from JSON to a Python dict. So Roman says basically don't stop there. Use the dictionary to populate a declared class and do so in a way that the keys in the dict aren't in the class, they get ignored. That way you're kind of fragile proof is really what it comes down to. Going that further step and getting into, say, a data class or something like that gives you the safety of more type info, and someone mucking with your keys upstream won't break your code.
Okay.
So he goes on to talk about, data classes and Pydantic, both of which give you more structure. Pydantic is a data validation and serialization library that includes a bunch of type info. I've actually been using it recently indirectly because I've been using Django Ninja, and it's built on top of Pydantic. So a lot of the serialization pieces and things like that are built using that.
That's a tool for API design, right?
Yeah, for API design. That's right. And then finally, so Roman also points out that you can also use the mapping object, which is in the typing library. And it essentially gives you a dictionary that's a little more rigid. So you give it a pattern and then it solidifies the keys. And then if you try to use a key that's not supposed to be in there, it's disallowed. So this gives you, again, more type safety, right? So remember when I said I had 2 articles?
Yeah.
Well, the next one is called Just Use Dictionaries, and it's by David Vujic. I don't believe it was written explicitly in response to Roman's article. He doesn't mention it, but it really could have been. David's premise is don't overuse classes. Dictionaries are often good enough. And the first example he uses shows a data relation problem where you're mapping desks to offices. And the class-based implementation gets messy quickly because you've got this nested thing. You have to have an office type and a desk type and, the relationship between them. And the dictionary, it's like, I have a list, and that's it. I have a list. And so, of course, the dict doesn't have the type safety, but David's argument is, you know what? There's about a third the amount of code here, and less code means less code to maintain, and you're probably better off from that perspective.
Right.
So he goes on to comment that as programmers, we have a natural inclination to want to define objects for things. Our data often maps to physical things in the real world, so it makes sense to want to encapsulate it. And this goes double for those of us who've spent a lot of time in the Java or C++ worlds, because it's ingrained in you. Right?
Yeah, we're going to make classes.
Exactly, right? And he argues, though, that this really is just often overkill. He goes on to talk about data classes in Pydantic, and it's not like he says don't use them. He just says they have their uses, and here's some examples where they shine. But if you're not doing these examples, is it overkill? So fundamentally, David's argument is the KISS principle. Keep it simple, Sam. That's what the second S stands for, right?
Yeah, silly.
Sure. So these articles have varying viewpoints. Something neither of them really talks about, though, that I find is important is scale and scope. They both seem to be do it this way. And my argument is, okay, are you maintaining 1 million lines of code? Well, Roman's got a solid argument for you. Are you writing something smaller? Well, then Roman's overkill and David's approach might be best, right?
That's what I was thinking about in that. Roman's approach is something where it's a bigger project and other people are going to touch it?
Yes, often.
All right.
Even for yourself, right? There's a maintenance cost, a mental maintenance cost once you get past a certain size, right?
Yeah.
And I think what happens oftentimes is folks get bit by somebody else's code, and then they start to become rigid and go, oh, well, it should never be done this way because that cost me 3 weeks of my life, right? So, yeah. When I was a younger developer, I wrote a lot of code thinking I'll reuse this. And that, again, is sort of towards that class mentality. But now I tend to wait to modularize until after I've written something a couple of times. So I kind of start with the simple, and then I go, which is David's argument. And then it's like, oh, this is getting bigger, it's getting unwieldy, then I'll switch over to the other side when simple isn't good enough.
Okay. That makes sense. I think I'd be right in the middle too. It depends.
Well, I think this echoes some of the type safety stuff we've talked about before, right? Like, it's not that it's not a good tool, but if I'm trying to write 100 lines of code and because my boss says so, I have to add typing information on this, it's like, it's going to take me twice as long. And why am I bothering, right? So,
right. But in the case of you using Pydantic in this new Ninja tool, like
Exactly.
it totally makes sense. Right.
Yeah, that's right. Yeah, with a couple key bits of type annotation, I've got the entire REST API spit out for me, and there's an appropriate use, right? So
yeah,
I know here I am arguing for reasonableness, and I'm sure the internet will
do you
love
remember in episode 118? Yeah. Snyk doesn't just find vulnerabilities in your code, open source dependencies, containers, and cloud infrastructure. It also provides expert remediation advice and automatic fix PRs, so you can merge and move on knowing that your applications are secure. And since Snyk was designed for developers, it works right from your favorite dev tools, like PyCharm, Git, CLI, and more. Start your free forever account at snyk.co/realpython. That's snyk.co/realpython. So when you saw this article get in the feed, you immediately were like, all right, I know who's going to pick this one. And you were right. So it's titled Procedural Music Composition with Arvo. And it's an article from Serge-Etienne Parent, and it's on a blog, deepnote.com. Let me start here. I have mixed feelings about procedurally generated music. The compositions created with it often, well, I just don't dig the results. They really kind of lack a lot of the humanity of music and kind of feel more like kind of mathematical proofs of what we could do with this. I think they can be super interesting. All of this, though, was super fascinating for me and has been a thing for me lately, where the technology and the ideas that are shown in an article or a tutorial or something like this gets my mind spinning, and I start really digging, if you will, into all these other areas. Often the digging is just provides a bunch of dirt and rocks, but occasionally there are some gems, and I found some really great gems through this that are kind of related. The article covers a tool called Arvo, and Arvo is it's a project that's by Dr. George Dimitrov, and the package is really kind of built on top of another package called Music 21, which is kind of out of MIT. And that package is a Python package that's calls itself a toolkit for computer-aided musicology. Music 21 is like a set of tools that helps scholars really look at music. Here, I'll read from it. Is a set of tools for helping scholars and other active listeners answer questions about music quickly and simply. If you ever asked yourself a question like, I wonder how often Bach does that, or I wish I knew which band was the first to use these chords in this order, or I'll bet we'd know more about Renaissance counterpoint or Indian ragas or post-tonal pitch structures or the form of minuets if I could write a program to automatically write more of them. So Music 21 is kind of designed to analyze music, but also potentially generate music out of it. I tried to read the documentation and I had a real hard time with it. It's real deep as far as what it does. And so what I liked is the tool that was created from it, this thing called Arvo, was taking it and sort of abstracting it again and allowing you to kind of create some stuff. And it has a bunch of modules built into it. And the modules that are in Arvo, let me see if I can find their names again. So the library has these built-in core modules. One's called isorhythm, and they're functions for generating isorhythmic constructions from pitch and rhythm sequences. Minimalism, which are functions that generate Philip Glass, Steve Reich inspired additive or subtractive processes, and then Tinabuli, which I don't know if I can know how to pronounce that, which is generating Arvo part inspired. These are based on like chords and kind of creating harmonies based on that. And then Then another tool called transformations that allow you to do inversions, transpositions, retrogrades, and these other kind of musical tools that could be really cool for, again, creating music that's in that vein. It also contains helper module for scales and sequences and other kinds of tools. And then it has a collection of samples. The tool can output to either like sheet music, which led me into this whole avenue of learning that there's this awesome tool for documenting music and kind of what sheet music can be in the world of the web today. And the W3C, the World Wide Web Consortium, I think is what it is, has created this thing called Music XML, and it's a way of sharing it. It's, I guess, been around since version 1 was 2004, and they're working on it still. So like version 1 was 2004, version 4 was released in 2021. Yeah, I wasn't paying attention to this, and even along with that, one of the gems I found is this thing called Muse Score, and you can get it at MUSE Score, SCORE.org. Totally free, open source notation package that is great. I was really impressed with it. I worked at music stores and I tried to sell, notation software, and it was multi-hundreds of dollars and super clunky to work with, not compatible with each other. And it was like all this kind of nightmares. And this is kind of breaking beyond that, which I was like, wow, this is really neat. So one of the things that you can do is with Arvo, it can export directly to it. So you can kind of see the sheet music and the kinds of things that it's generating, but also can output MIDI. The author of the package created a really nice YouTube video. So I think this tutorial that I'm referencing, the procedural music composition with Arvo, that's by Serge Etienne, is good if you're into kind of reading and following along, like a written tutorial. And it has a SoundCloud clips that you can kind of play to kind of get an idea what the stuff sounds like. But the creator, Dr. Dimitrov, actually made a YouTube video of him showing you how to use Arvo. And I was really impressed with that. And again, I sometimes want to watch a video just to kind of see the results. And then in the end, he's tying it all together and using this thing called Ableton Live to kind of get the parts and play with them. I'm just fascinated by this sort of cross section. And I found a bunch of interesting little gems out of it. I think that one of the things that I think is really kind of cool with this Music XML is that this idea that we could actually kind of build tools to read and write XML in Python, and kind of abstract some of the nonsense that XML sort of kind of raises the hairs on the back of your neck. Oh no, what am I going to get into here? And I think that there's a lot of these kind of tools that can kind of help with it. I think also Music 21 is a really fascinating project because of that it's able to analyze music but also output it. So anyway, bunch of resources if this is something that you're into. Again, it's a deep dive, but I had a lot of fun kind of digging into it, and I got to play with the packages a little bit, and I could see myself kind of using it as an idea generation kind of thing. Honestly, when I was done looking at the Arvo package, I was thinking, man, you could build kind of a nice GUI front end for this and be able to kind of play with it. So I'm thinking of a project for myself for it. So we'll see. I don't know if you're a big fan of of these kinds of projects, or do you listen to Philip Glass or things like that?
I've got history in it, but I don't do a lot of it now, I think is what it comes down to. So there's an interest in reading the articles because I'm like, oh, well, that's neat. And you could do this and you could do that. And then I look over at my piano in the corner that's slowly gathering dust and go, and when will I do that? So
yeah. Well, your next one's a real Python one, right?
It is, and it's another step-by-step one. This one's called Build a Tic-Tac-Toe Game with Python and Tkinter. And this article is, all right, Mr. Bailey, say it with me. Leodonis Pozo
Pozo
Ramos.
Ramos, yes.
Our listeners are going to start to think that he's bribing me or something. If you're listening, Leodonis, 15-year-old Havana Club Gran Reserva, just so we're clear. Anyways, as you might guess from the title, this is a project-based article. If you haven't played with Tic-Tac-Toe before, that's a TK-based GUI library for Python, and TK is a set of underlying GUI libraries that several different programming languages have built tools on top of. I'm not sure whether this is a regional thing or where I just hang out, but I've often heard Tic-Tac-Toe pronounced as Tinker, which is like a purely dyslexic thing. So excuse me if I slip into that here.
Mine is Tkinter.
Tkinter,
yeah.
I think it's not meant to be pronounceable. Playing with this was kind of fun. I had flashbacks to about 25 years ago. I used to write Tickle TK applications with C++ backends. So it was kind of nice to see that TK is still around, and that I can do this in Python is even better, because it's a pretty quick and easy thing. And in fact, a lot of the time when I'm messing around with CSS, I look at it and I go, but all you have to do is learn how TK put these things together, and none of these problems would exist. This is much easier.
Yeah.
But anyways, you don't want me starting to rant about how the web is broken. And the article is broken down into 5 major steps. So step 1 is setting up the GUI and the main parts of the tic-tac-toe board. The second part is creating some game logic. Then third is processing a player's move, which includes things like checking for winning and tying states. The fourth is then handling the player's move in the GUI, so showing that stuff, updating the display. And then final is just some polishing, adding a menu and that kind of thing. So Tinker does come with Python, so in theory, you don't need to install anything. But to quote Yogi Berra, in theory and practice are the same. In practice, they're not.
Yeah.
The caveat here is the article uses features out of Tic-Tac-Toe 8.6. And if you're running Python 3.9.8 or more recent, you're good. It's there. If not, you might have to upgrade your Tic-Tac-Toe installation to get it to work. Then there's some stuff in the article about how to do that depending on what platform you're on, some pointers. Yeah,
it's kind of fascinating. I think a lot of people maybe didn't know that this is one of those batteries that's, in there in the...
It's a really big pile of batteries. And some of the batteries do the same thing, as much as we say that they're not supposed to. But yeah, there's multiple GUI things built into Python. So
yeah, the turtle and Tkinter is like right there.
Yeah, there's some corners.
So, yeah, definitely.
First part of that project then is talks about sort of the classes and the widgets that you need and how TK puts those things together, how you glue the buttons into the tic-tac-toe sort of design. And at the end of that step, you actually have a thing you can play with. You can push the buttons. The buttons don't do anything, but you can push the buttons. And then it moves on to start the construction of, this is actually a 2-player game, right? So you would click and then your opponent clicks, and it shows you some code for figuring out, okay, how do I know what patterns on the board are wins or losses? And then tying that back into the GUI so that if I click, now I'll check, okay, has that changed the state of the board to a win or a loss or a tie? How all those pieces fit together. So it's a nice, if you're new to the GUI world or you're new to Tic-Tac-Toe, this is a nice little way of sort of going through and introducing to it. It's not exactly beginner's material. So if this is your first Python project, you might want to start somewhere else. You've got to be fairly comfortable with the concept of classes and list comprehensions, some basic data stuff, dicts, name tuples. But if you've got that, this is a nice way to play around and do some new stuff. And they've got a really good section on sort of the prerequisites that lists out a bunch of other articles.
Yeah.
So if you need a refresher in any of those things that I just listed, you can go off and click through on all of it.
Yeah. I'm liking that structure in the articles lately for that. Again, like the one I was mentioning earlier.
Yeah, no, it's a great way to do it. So you can kind of know what you need. And if you don't have it, you can go click that first and come back. So
cool.
As expected, all in all, top-notch article. And there, Leodonis, there's some rum-worthy praise if I've ever heard it. So I'll send you my address.
All right. This week, I want to shine a spotlight on another Real Python video course. And it's about a topic we're discussing this week. When you're starting a project, one of the big decisions you need to make is how are you going to store and work with data? Python provides a variety of built-in tools. This course is titled Dictionaries and Arrays, Selecting the Ideal Data Structure. The course is based on a real Python article by Dan Bader. In the course, my co-host, Christopher Trudeau, is your instructor, and he takes you through what are the advantages of using the built-in dict type? What are 4 other types of Python dictionaries? How list and tuple types are arrays? What are typed arrays, and how can they save memory? What are the different arrays for storing binary data? What are practical uses for the different types? And finally, how to select that ideal data structure for your programs. I think it's a worthy investment of your time to learn the variety of ways of storing and managing data in your Python programs. The choice of a right data structure will affect the readability of your code, ease of writing, and performance. And like most of the video courses on Real Python, the course is broken into easily consumable sections and has code samples for the techniques shown. Like all of our courses, it has transcripts and closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. So we're back to doing a discussion. This one is from Matt Harrison, and he has been asking kind of questions to his audience on Twitter. And this one was, what is the most common issue you have coding with Python? And I think there's lots of ways that you can take the word issue, and people definitely did in the thread, which was interesting. And he tried to answer some of them, and then a lot of other people were trying to reach out and help too. But I thought it might be interesting. Like, I guess one of the ones that I saw that I kind of related with was this setting with copy warning, which I think I've already mentioned before. And he was on the show talking about it also, that there are ways that you would never see that. But that was something that literally that warning would come up in the code I was working on as I was, beginning to work in pandas, and people would just wave it away. What? It's just a warning. I'm like, yeah, I don't think this is good. So I don't want warnings in my code. I don't know if you want to get into it. Like some of the stuff, again, are common beginner things that people have trouble with, virtual environments, and the idea of packaging, just some straight up complaints like pip install never works. And I'm like, wow, okay. I don't know where that person's gone wrong.
Yeah. I saw that one. Yeah. I'm not sure what never means, because I don't think I've ever had a problem with it.
I don't either. Yeah. I mean, I had problems initially with like the concept of virtual environments, or just forgetting to turn it on and, just being in a hurry and like, where did I just install this? I have solved that problem. So again, some of the commonness of the issues have shifted over time. I think probably one of the big ones for me is forgetting. We just mentioned all the built batteries of Python, but sometimes I just forget to use built-in stuff and remembering that. And it's almost kind of cool. Like I had an episode that just came out talking about refactoring, and occasionally I would use a tool like Sorcery, and it would be like, hey, this thing exists. And you're like, yeah, oops. You're right. That would have been better. So that's a common one for me. What are some of yours?
I have a horrible habit of copying, pasting a line either out of a function or a dictionary and forgetting the comma on the end, and turning something into a tuple that isn't supposed to be a tuple. And I know what someone's going to tell me. Well, if you did type checking.
You wouldn't see that.
The other one I find, which isn't really Python specific, but because I do a lot of web, I'm back and forth between Python and JavaScript.
Yeah.
And so it's what ends up happening is you end up like writing half of each language in the other language, and it never works in either case. So I'm often accidentally using def instead of function inside of JavaScript, or putting a brace bracket somewhere inside of the Python and going, oh yeah, that's right, that's wrong language. And a subtle version of that one as well is enumerate the order of the index and the value that comes out of it. Different languages have similar concepts, but put it in different orders. So I frequently will end up going, why has that got a number in it? That shouldn't have a number. Oh, right, that's the index, right? So I get them backwards. And you mentioned the being in the wrong virtual space, because I run on a Mac. The base Python install is still 2.7. And so sometimes I'll quickly run a script in a screen somewhere that I haven't enabled the virtual env for, and and it
Right.
just dies because there's syntax errors in it because it's Python 3, right? So yeah, it's to me this is very little of it I noticed as I was going through, except for maybe the tuple thing. As I was kind of thinking about it, very little of it is Python specific. I think a lot of it is just programmer be programmer. So
Yeah. To kind of go over to, again, one of the common ones I saw in this list of stuff that I never have this problem, and I just kind of get confused by it, is the nesting and indentation thing. Yes, I did have that problem once working like through tutorials. Like I was doing stuff that was very, very class heavy, which was like working in Pygame, where I was embedding things and like making sure I had the indentation right. But that isn't as much of a problem for me now. I can see how that can be, because it's like that's the crucial sort of structural element in Python. The other ones that I kind of run into now are similar to what you're saying of like, I feel like it's my office, like my coding environment and the way that it's set up. I am constantly jumping around, running lots of other people's code. And I feel like often I need to just stop and I need to like spend some time on like getting this the way I want it. And it's just this thing that it's going to be unique to me because I'm kind of like looking at lots of other people's stuff often, not only within an organization, but also, I'm researching projects and the stuff that we bring up here on the show. And often we have this sort of meeting where we kind of decide on like, okay, what do you want to talk about this week? And then we kind of are picking and choosing. And sometimes that changes within the next day. And we're like, okay, this did not work out. And that's often because I'm not able to just even follow the way that they've described how this stuff is set up, or there's like version or hardware conflicts. Those are the things that are causing, if you will, the issues for me now, is just like, getting things to the end point, like getting past sometimes these projects and getting them going. And so I don't know what my solution is there. Like I've thought about going beyond even like usually it's virtual environments, which has been good, but sometimes I'm doing bigger things and I'm wondering, okay, well, maybe I should go have this on Colab or some other kind of thing. And so I'm not decided. And the other one that is old that I had problems with was, and I've mentioned this before in the show earlier on, is in Jupyter Notebooks, not knowing what the current state is because I was exploring and having to just, okay, let's just start from the beginning and run these cells,
yeah.
and kind of start over. And so that was probably, some of the pain points that I was feeling. Were there other ones in the list of stuff that he had there that you brought up that other people were feeling?
A lot of it's it's the internet. So someone said Python, so someone says white space and copy and paste, right? That's kind of it is. And someone else says performance, and the latest answer to any time anyone says performance is, but 311 is going to be better. And it's like, yeah, it's like, yeah, okay. So you said Python. I'm surprised someone hasn't made a snake joke. And since you're all very original. There was, a little bit of a callback to your MkDocs thing there. There was a few places that were like very project specific going, we should get the people from this project to write the docs for that project because these guys rock and that stuff's horrible, right? So there's a little bit of that sort of specific pieces.
I wonder about that because I follow a few developers that are in the Apple sort of ecosystem, and they all just complain so often about the documentation that is part of like say Swift or Apple's APIs for their hardware, that it's just not complete. And I wonder, as a language, I feel, or even just the ecosystem, like I feel like the documentation generally in Python, or at least stuff that I've chose or selected to use, is pretty well documented. But I don't know. Again, I'm one of these people that my experience kind of starts at this sort of halfway point, like I was doing programming before the internet and then stopped and then picked it up, recently. Do you feel that way?
I suspect some of it is age of language. So because Swift is still relatively new and because it's fed out of a corporation, your primary documentation mechanism is going to be that corporation.
Yeah, from them. Okay.
And because Python is open source, if you don't like the documentation, contribute to the documentation. And because it's been around long enough, people will have done that, right? So
yeah. Okay.
and that's it, honestly, it's a complete tangent, but it's one of the easiest ways of contributing, right? So I mentioned earlier, I've been playing around with Django Ninja, and there was I needed to do something, and I posted, and the maintainers are fantastic. They answered very, very quickly. And I was, okay, that's great. And I'm like, okay, maybe I missed it. Maybe I missed it in the documentation. And I looked and it wasn't in the documentation. I'm like, okay, fine. I'll write 2 paragraphs and give you a merge request. So the next person doesn't have to ask that question, right? It's the easiest way of contributing to somebody's package, right? So, I think over time, this is what happens: is that it gets built up, right? So
yeah. Well, I think that brings us into projects. If I hadn't had enough fun with XML earlier, I found a project that is probably one of the smallest projects I've ever talked about. It's really simple and really small, which I like about it. It's svg.py, type-safe library to generate SVG files. Why do I care? Well, I was interested in SVGs. If you're not familiar with it, scalable vector graphics. I've always kind of been fascinated with vector graphics, and I think they're really kind of cool in the sense that you can scale them to whatever size that you want. It's a very different sort of art style from raster stuff. I never owned a Vectrex video game system, but I was fascinated with it. Anyway, so SVGs, I had to do some work where somebody wanted me to create like a logo for their company. And I'm like, I'm going to do this. I'm going to learn how to do this. And so I was working with different tools and so forth. And I don't get hung up sometimes. And the XML that is the SVG sort of standard is another W3C thing. It's just sort of complicated, and having a library that can kind of turn that into Python objects and make it simpler, I think is really great. It's by Orsinium is what he goes by on GitHub. His first name is just Graham. That's all I see on there. Graham from the Netherlands. Features of the package: compatible with all SVG standards, 100% type safe, pure Python, no third-party runtimes. It's the fastest thing I've pip installed in a long time. It was super quick. No deprecated attributes, only what actually works. The same names and structures are as in the standard. If you know how to write SVG files, you'll know how to use this library. And it's based on a schema that's part in the Mozilla MDM reference, the svg-xsd schema. So that was a little rabbit hole I went down again. Lots of nice little examples to get you started. And yeah, I don't know if you're going to need to output SVGs, but like, they're really kind of nice. They're super, super small because it like literally outputs just text, if you will. And they can describe really kind of complex shapes. And then again, they can be scaled to whatever size. So I think of like background elements. I think of just general shapes of other things. They're everywhere, but you may not know that it's possible to create them. So.
And now that browsers support them directly, I'm finding they're becoming more and more common inside of web pages. So you'll see them for things like logos or for icons and things, that rather than using an icon library, they just directly embed the SVG right into the HTML.
Yeah, I'm wondering, like, some of those common glyphs that are in some of these other libraries that are out there. I'm sure a large number of them are SVGs. But anyway, I've thought about going in and working in the XML itself and then just sort of like shaking my head and going, nope. And so this is kind of a nice way to kind of at least stay a layer above it and be working in Python. And it has a nice way that you can kind of just pipe the output right into a file, a .svg. So anyway, nice, simple little project. What's yours?
Well, it's nice, but wasn't simple.
This took a little bit.
So it wasn't too bad. It's just it wasn't a quick install, shall we say.
Oh, okay.
So this is a tool called semgrep. It's a multi-programming language semantic analysis tool for evaluating code. So if you've ever used something like SonarQube, this is similar to that. So it's one of these quasi-licensed things. So it is open source, but it's from a commercial company with a commercial offering. So there's a command line interface that you use to evaluate your code, and it does that locally. So they swear up and down that they do not send your code up to the server, but they do send a bit of metadata. So depending on your comfort level with that, you might want to dig into, they've got a good privacy policy and everything, but, if you want to be paranoid, you should know that. So there are ways of controlling it, but if their rule registry for what analysis to be done is actually on their servers. You run the command, it gets the latest rules for whatever files you need, and then runs it on your thing. So I ran it on a couple different projects. One was one of my own libraries, and the other was a client project. Was very impressed with the results. I didn't see any false positives. Everything it complained about was something I probably shouldn't have done. So that's always good.
Okay. Nice.
The library that I was talking about is a set of utilities for Django projects. It found not only the Python in the library, but also some bash scripts and YAML files and did analysis on those as well. Warned me about a spot where I might accidentally be trusting some user input that I shouldn't be. Highlighted a spot where I was bypassing the password validation. Bad boy. And, leaves it to security flaws for insecure passwords. And even inside a couple of the Django template files, it highlighted the fact that I wasn't using the integrity argument on a link tag, which of course is dangerous for cross-site scripting attacks. So it was pretty comprehensive from that perspective.
Nice.
The client project is a single page application using Django DRF on the back end and Vue.js on the front end. So it ran analysis on the Python, Bash, the HTML, the Django, and JavaScript, and it even found like some JSON data files, which it validated. This one got ugly fast. It had 89 findings, which is a kinder way of saying you're an idiot. Thankfully, I had included some third-party libraries in this repo, so my ego was soothed a bit by the fact that not all 89 were my fault.
They're not all my findings.
Yeah. On the other hand, the dangers it was highlighting are still in the code, and that was being shipped, so that's always its fun thing. Semgrep does support writing its own rules, which is kind of cool. It uses a YAML format with the code matching part looking like code itself. So you're not having to write some horrific regex. So if you were, the example they use on the website is you want to catch print because you don't want print in production because it spits stuff out to the logs. Essentially, it says, the rule is print bracket ... bracket, and it finds them all. So nice and clean.
Cool.
Their rule registry is open for contributions, and each rule gets its own license type. So most of them are open source. I think they're MIT, if I remember correctly. And some of them are owned by the company themselves. So you're allowed to use their rules as long as you're not charging for them. So they don't want you setting up a competing registry. But they were saying, even if you're a consultant and you want to use it at your client and you're getting paid to do that, they're fine with that. They just don't want a competitor popping up on the web, which seems fair.
Right. Using all their, we saw a tool that does the same stuff. Okay.
Exactly. And so the one last but important feature to me is it supports an ignore pragma. So put a little comment in your code to tell semgrep, I understand this finding, but I don't want you complaining about it, which is good because sometimes, you just want to ignore certain rules, or maybe if you get a false positive, you want to comment them out, because if you get 50 warnings and then you get used to the idea of there being 50 warnings, you're not going to notice when there's 51. So you're better off, getting down to 0 each time you run a tool like this. It's just better practice.
Yeah, lower the noise floor. Yeah,
exactly. So definitely worth checking out. And the next time I'm working with a team that's using SonarQube or they're evaluating it, I think I might set up a head-to-head comparison and see how it goes.
Cool. Yeah, that's interesting. It kind of almost hits two of the things that I've talked about recently. We were talking about kind of code quality metrics and so forth, but then also just it seems like a lot of the findings are security findings that are kind of, I don't know if it's semgrep help with some of the quality metrics of things, or is it kind of always just sort of looking for specific rules?
I think it's a rules matching engine. Maybe I didn't dig in enough. Maybe it's there, but most of the concentration, everything I played with and any of the documentation I saw was really more around, the code smell type stuff.
Okay, cool. Nice. Well, thanks for gathering all these articles again this week, and thanks for coming on the show again, Chris.
Always a blast.
And don't forget, Snyk is the developer security platform that's loved by devs and trusted by security. Sign up for free at snyk.co/realpython. That's snyk.co/realpython. I want to thank Christopher Trudeau for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.